Don't forget to like, subscribe and share the videos.
The topic that we are going to discuss now is cloud seeding. What is cloud seeding? Why is it in the news? Let us understand one by one. So cloud seeding, which is a groundbreaking technique to enhance rainfall. Cloud seeding is used to enhance rainfall, and this has taken the center stage in the recent study published in the in the Journal Bulletin of American Meteorological Society, and this study was conducted by Indian Institute of Tropical Meteorology, which is there in Pune. Okay, so they have conducted this study about cloud seeding and what are all the findings of the study, and in general what is cloud seeding, what are all the different types of cloud seeding, how does it happen, and all those details we'll be understanding here. And this study unveils the potential of cloud seeding to boost precipitation in water scarce region. Obviously we need cloud seeding in water scarce region, thus offering hope for tackling drought conditions. So this is what we need to know. So the experiment that they have conducted or the investigation that they made is this one, that is cloud aerosol interaction and precipitation enhancement experiment. That is what the experiment that they have conducted, and this is the phase 4 of this particular experiment, which lasted for 2 years, that is 2018 to 2019, the summer seasons. The summer monsoon was covered, and this was done in Solapur, which is there in Maharashtra again. Okay, and its primary objective is to assess the effectiveness of hygroscopic seeding. So this is one type of cloud seeding, that is hygroscopic seeding. Details about it will be coming in the upcoming slides. Okay, so and it is also done in deep convective clouds. What are these convective clouds? That also we need to understand. What are all the different types of convective clouds that we have, will be knowing. Okay, and to develop a cloud seeding protocol, this was also the main objective of this particular experiment, that is CAIPEEX. Okay, to develop cloud seeding protocol. Next, researchers have used this chemical, that is calcium chloride flares was used for cloud seeding in this particular experiment. Okay, so in this hygroscopic seeding experiment, calcium chloride flares was used. This is important from exam point of view. And a cloud seeding flare, what does it do? It releases the particles when triggered. Okay, this seeding was done at the base of the warm convective cloud. This is also important. It is done at the base of the warm convective clouds and not on the top. It is done on the base. Okay, say for example the cloud is like this, it is done at the base. Okay, the seeding is done at the base so that effective seeding happens. And it is also done at a time when the clouds were in their growing stage. This is also important. So when the clouds are in growing stage, this seeding has to happen so that the seed particle cloud enter the clouds with minimum dispersion. So there is no need of much dispersion when the seeding is done in the growing stage itself. Okay, so this is what we need to know. This is the experiment. Now let us understand what are convective clouds. In the previous slide we saw that this seeding was done to warm convective clouds. So what are these convective clouds and what are the different types of convective clouds, we need to understand. So convective clouds are clouds that form when warm humid air rises through cooler air in the atmosphere. This is what convection is. So convection is vertical movement of air is called as convection. Okay, vertical movement either upward or downward. If there is a movement of wind or air vertically, then that is called as convection. Okay, then if it is horizontal, then that is called advection. That is called as wind. Actually advection is wind, this is air movement. Okay, next, the warm air is less dense than the surrounding air, so it rises, and this process is called as convection. This is obvious, right? The air which is warm will be very lighter. Okay, it is less dense, thus it rises. And then convective clouds are also known as cumuliform clouds. This is important. Okay, it is also called as cumuliform clouds, and they look like stacks of cotton balls. That is why it is called cumuliform. Okay, it looks like stacks of cotton balls. So it will be like this. Convective clouds will be like this. So it will be looking like cotton balls dispersed. Okay. Next, there are three types of convective clouds. First one is cumulus cloud. They are together called as cumuliform clouds. And the first variety, the first type that we are seeing here is cumulus clouds, and they are fluffy white clouds with flat base and they are rounded at the bottom. So it will be like this. This is cumulus cloud. It will be having flat base and then it is rounded at the top. Okay. And then there is another clouds, that is cumulonimbus clouds. So cumulus clouds can develop into cumulonimbus clouds, which are associated with thunderstorms. So this cumulus clouds will be developing into a cumulonimbus clouds. This is cumulonimbus. This is cumulus. Okay. So this is called as a towering cloud. Towering. It goes like a tower. Okay. So cumulonimbus clouds which are associated with thunderstorms. So cumulonimbus clouds are responsible for thunderstorms here. And there is also another type of cumuliform cloud that is called as cirrocumulus cloud, which is high altitude clouds that appear as small white and fluffy cloud patches, and they often have a wave or honeycomb like pattern. Okay. So such high altitude clouds are called as cirrocumulus cloud. So the word cirro means high altitude. Okay, this must be kept in mind. So let us see the pictures of these clouds so that you will understand it better. So this is cumulus cloud. It is low altitude. See, cumulonimbus clouds, it is both low altitude, mid altitude and also high altitude. All these three are there. And then there is cirrocumulus cloud, which is like this, which is there in high altitude regions. Okay, so this is, all these together are called as cumuliform clouds because of its shape, that is like cotton balls. Okay, so all these three looks like cotton ball, this one and this one. Okay, so this is what we need to understand from this particular thing. And now let us get into the details of what is cloud seeding. Okay, because that is what the topic is, and here the cloud seeding is done in convective clouds, and these convective clouds are called as cumuliform clouds, or also known as cumuliform clouds. And there are three different types of cumuliform clouds, that is cumulus, cumulonimbus and cirrocumulus. Now let us understand what cloud seeding is. So cloud seeding is the process of artificially generating rain by implanting clouds with certain chemicals, okay, certain particles like silver iodide crystals. Very famous one is silver iodide crystals here. And this cloud seeding uses planes to spray the clouds with chemicals to condense water particles into larger rain droplets. So there will be smaller rain droplets. When there is a seeding happens, then this seed will attract these rain droplets so that it will form like this. These rain droplets will get attracted to this seed, that is the chemical particle that is being dispersed. And see, comparatively to this one is like a bigger drop. Okay, so it will become like a bigger drop than this is a very big drop. Okay, so this is how we are going to increase the drop size, okay, the droplet size, thus it will induce precipitation. Okay, and what are all the application of cloud seeding? One application is done to enhance the winter snowfall and to increase mountain snowpack. Why are they doing this? To supplement the natural water supply for the communities who are living in the surrounding areas. And cloud seeding can also be done to prevent hailstorm. This is also important. Okay, hailstorm is like an hazard. Okay, it is not something which is expected. Okay, so hailstorm should be prevented with the help of cloud seeding. It can be prevented with the help of cloud seeding. And cloud seeding is also done to dissipate fog and also to induce rainfall. This one is the main use of cloud seeding, that is to induce rainfall in drought prone area. Other than that, it is also finding applications in somewhere, in many other areas like preventing hailstorm and also for dissipating fog. And it also reduces air pollution, because when there is fog surrounded, then it causes air pollution. Okay, which may mixed with smoke and form smog, which is air pollution. Okay, so in all these applications, cloud seeding can be used. Next is, so this is how cloud seeding happens. First is, an aircraft injects silver iodide or any other substance into atmosphere. So this is how the seeding is done. So all these particles are seed particles. Okay, and then the chemicals mimic the particles that serve as the surface for condensation that creates water droplets, like we saw. Okay, so they will attract those water droplets, and once the condensation creates water droplets that are large enough, then rainfall happens. Okay, so when there are large rain droplets form, then surely precipitation will happen. So this is how cloud seeding works. Next is the three methods of cloud seeding. The first method is called as static cloud seeding. Here, like we saw in the previous slide, it is the same thing. Okay, so it involves introducing ice nuclei like silver iodide, or even dry ice can be used here, into cold clouds. Okay, that have super cooled liquid water droplets. Okay, so when there is super cooled liquid water droplets and they are not so big, those droplets are not so big to fall as precipitation, fall as rainfall. So this clouding, this seeding is being induced, and the ice nuclei can trigger the formation of ice crystals and snowflakes, which can grow at the expense of the liquid droplets. Okay, so there will be liquid droplets, and at the expense of liquid droplets, this snow forms. Okay, this is the seed. Okay, around the seed, all these liquid droplets get accumulated. So this is how it happens. So it happens at the expense of liquid droplets, and it falls as precipitation. When the droplet is big enough, it falls as precipitation. Next is the dynamic cloud seeding. This is another type. What is dynamic cloud seeding? It means it is also a method of inducing rain by boosting vertical air currents. This is very important. So they are going to boost vertical air currents within the clouds for condensation to happen. This is another method of cloud seeding, where no much chemicals are involved, but then air circulation is induced among the clouds. Okay, vertical air currents is induced. Next is, this process is considered more complex than the static one, because it depends on a sequence of events which has to work in a proper manner. Okay, so this is complicated than the previous one, that is the static cloud seeding. Another method we have is hygroscopic cloud seeding. What is this hygroscopic cloud seeding? It is a method which involves spraying fine particles of hygroscopic material. What are hygroscopic materials here? Those material which are able to attract water. Either it can absorb water or it can adsorb water. Okay, what is the difference between absorption and adsorption? Absorb and absorb. Absorb means the water is taken inside. Okay, it penetrates inside. Whereas adsorption means it is a surface phenomenon. The water is sticking to the surface of any other substance. That is called as adsorption. Okay, so hygroscopic material can be either absorption, it can do absorption or adsorption. So either way, it is attracting water molecules. That is why it is hygroscopic materials. And here the best hygroscopic material is salts. Okay, and these salts are sprayed through flares or explosives into the base of the warm clouds, and then the particle can act as cloud condensation nuclei, as we already saw, and increase the number and size of the cloud droplets, which can enhance the reflectivity as well as the stability of the clouds. Okay, so this is hygroscopic cloud seeding, the third variety. Now let us understand what are all the challenges there in cloud seeding. The first challenge here is the presence of moisture filled clouds. This is one thing. Okay, so there is compulsory need for moisture filled clouds, then only cloud seeding will be happening effectively. If there is no enough moisture in the clouds, then cloud seeding cannot happen effectively. Next is, it does not occur during the times when additional precipitation would be a problematic thing. Okay, such as times of high flood risk or busy holiday travel periods. In those times, or in festive seasons and other seasons where people are coming out, then in those times cloud seeding cannot be done. Next, this is important. This cloud seeding may have negative effects on the environment and health of human beings, like altering the natural water cycle. Okay, naturally water cycle is happening due to precipitation. Okay, but then we are inducing it, we are enhancing it artificially. Okay, so it will alter the natural water cycle and contaminating the soil and water with chemicals, because we are adding chemicals like silver iodide, dry ice, and calcium chloride we saw in hygroscopic cloud seeding. So all these salts and other chemicals is going to affect the soil and water, and it is also affecting the local climate. This is also happening, okay, because the natural cycle is being disrupted here.